Hey guys, Mr. B here, and this video is going to be doing some practice writing ionic compound formulas as well as naming them based on their formulas. So the sheet that I'm going to be doing here will be found in the description of this video. It is a PDF, so I am using Cami to be able to type and write on it, which if you have the extension on your Chrome browser, you will be able to do as well. All right, so there's some notes here on the front sheet before we get to the problems. So we're just going to read through this real quick and go over some examples, and then we'll get into doing some of the problems. So it says ionic compounds are compounds formed by the combination of a cation and an anion. So basically, again, metal and a nonmetal. Ionic compounds are more commonly known as salts. The word salt, you probably heard of the word salt or table salt, which is specifically sodium chloride, but the word salt is a chemical word for basically all ionic compounds. So there are lots of different types of salt. Anyway, so binary ionic compounds are compounds containing only two elements, as demonstrated in the examples below. When writing formulas for ionic compounds, we use subscripts to indicate how many of each atom is contained in the compound. Okay, subscripts are these little numbers that are written down below. So like in this example, CaCl2, that little 2, that's a subscript. Okay, we use those to indicate how many of each atom we have. And it says, remember that even though ions have charges, ionic compounds must be neutral. Therefore, the charges on the cation and anion must cancel each other out. In other words, the net charge of an ionic compound equals 0. So the overall positive and overall negative charges need to balance each other out. They need to be the same. So first example, it says for a salt containing a sodium ion, which is Na plus 1, and chloride, which is Cl minus 1, the ratio is 1 to 1. The positive charge on the sodium ion, which is positive 1, cancels out the negative charge on the chloride, negative 1, we get 0, which means the formula for this salt is going to be 1 sodium, Na, and 1 Cl, right? So NaCl. And it says the actual formula is Na1Cl1, but in chemistry, we typically don't write 1s, so we just write NaCl. Here's another example. For a salt containing a calcium ion, Ca2+, and chloride, Cl minus 1, the ratio can't be 1 to 1 because calcium is positive 2 and chloride is negative 1. If we put those together, we'll get an overall result of positive 1. We need those to be equal to 0. So it says, remember that ionic compounds must be neutral. In order to yield a neutral compound, two chlorides must bond to the calcium ion. So we need two chlorines, each with a negative 1 charge, which will give us a total of negative 2, to balance out with the one calcium that has a positive 2. That will give us a charge of 0, which means our formula then will be 1 calcium, so Ca, and 2 chlorides, Cl2. All right, and when it comes to naming, when naming ionic compounds, remember that the element name of the metal followed by the ion name of the nonmetal. So basically, the metal ion is always written first, the anion name is always written second, and we just stick them together. So NaCl is sodium chloride, CaCl2 is calcium chloride. And remember that the negative ions have that "ide" ending on them. All right, so let's take a look at some examples here. Okay, so starting out with number 1, it says, name of the ionic compound is sodium bromide, formula of ionic compound. Okay, so they want us to write the formula for sodium bromide. Now, the first thing I'm going to do is I'm going to find sodium and bromine on the periodic table. I'm going to find their formulas and their element symbols and what charges they make as ions before we then put these together as a compound. So we have sodium, which is Na over here, and bromide, which is Br. Sodium is in column 1, so it makes a charge of plus 1. Bromide is in column 7, so it makes a charge of negative 1. So we have Na, and then this little symbol here, so Na plus and Br minus. Okay, so when we put these together, we have Na plus 1, Br minus 1. So those are already the same size. They're already the same in terms of their charges, like positive 1, negative 1. They would balance each other, which means our formula is simply just going to be NaBr. 1 sodium, 1 bromide. And that's it. All right, let's take a look at number 2, calcium chloride. So let's find calcium on the periodic table. Okay, it is here in column 2, so it makes a charge of plus 2. We have chloride, which is in the same column as bromine, so that will make a charge of negative 1. So here we can have Ca, which is 2 plus, and we have Cl, which is minus 1. All right, so now at this point, we see that these charges are not the same. So we can't just take one calcium and one chlorine and put them together because the calcium has a larger charge than the chlorine does. We need them to be equal. So I'm going to show you on my paper real quick, again, our little method of doing this that I like to call the Wonder Woman. So we're going to have Ca 2 plus and Cl minus. And what we can do is we can take the charge on the calcium, or the number, the 2, drop it down onto the chloride, take the 1 and drop it down onto the calcium. So we're going to have Ca, and we're not bringing the negative, okay? We're just going to bring the number, which is a 1. So Ca1, and then we're going to have Cl, and it's going to have a 2 on it. And again, we're not bringing the positive part. We're just bringing the number. So we have Ca1, Cl2, and again, grammatically, we don't write ones. So grammatically speaking, this would be written incorrectly. Correctly would be CaCl2. Now, there's one other thing we need to do here. And in this example, we don't need to, but we may do this in other examples. And that is, if these numbers can be reduced, meaning they have a number that is a common denominator, you can divide out from both of them and simplify them down, you have to do so. Okay, so there will be an example probably that will pop up here later that will show this, but basically these numbers need to be reduced if they can be. So one example of this might be like Ca and oxygen. So calcium, which is 2 plus, and oxygen, which let's just show on our periodic table, oxygen here. Oxygen is here in column 6, which makes a negative 2 charge. So oxygen is going to be 2 minus, okay? So if we had these two ions and we did our Wonder Woman, so we take our 2 and from the calcium, we take our 2 from the oxygen and we drop it down, we would have Ca with a 2 on it, again we don't bring the negative, and an O with a 2 on it, again we don't bring the positive, and this, even though this might look correct, we do have to reduce this because both of these numbers can be divided by 2 and they can be simplified down to be Ca1O1. And again, grammatically speaking, this would not be correct, so you just write this as CaO. Okay, so that is one thing that was not mentioned in the notes that is important, is when you do the Wonder Woman, you do need to make sure that if you can reduce these numbers, that you have to simplify them down and reduce them. All right, so let's go back to our problems here. So for this one, Ca and Cl we found was going to be Ca, Cl, and then there's going to be a 2 on the chlorine, okay, to balance out those charges. All right, let's take a look at number 3, magnesium sulfide. So let's go find magnesium on the periodic table, and sulfide is sulfur. So Mg is magnesium, that is in column 2. Sulfur is in column 6, the same as oxygen. So let's erase some of these other ones here so they're easier to see. So we have Mg, which is 2 plus, and S, which is 2 minus. So again, here is an example of what we were just talking about. So first we have Mg, 2 plus, so let's write that in there. Then we have S, which is sulfur, and this is going to be 2 minus. And now, again, let's switch back to our paper to again show how we do this. Okay, so we have Ca, 2 plus, and S, 2 minus. If we do our Wonder Woman, we will take the 2 from the calcium and drop it down onto the sulfur. Take the 2 from the sulfur and drop it down onto the calcium. So we'll have Ca with a 2 on it. Again, we don't bring the negative, just the number. And S with a 2 on it. And again, we don't bring the positive. We just bring the number. And now at this point, again, both of these have 2's, which means that we have to simplify them because we can. So we'll need to divide a 2 out from both of these. So they will both reduce down to a 1, like this, Ca1S1. And then grammatically speaking, again, we don't write the 1's. So you'll just have Cas as our proper chemical formula for this compound. Okay, so let's go back to our sheet on our notes, or not our notes, but our practice sheet, and let's write this in here. So we have, oh, this is not, I wrote calcium, I'm sorry, this is magnesium. So that whole problem that I just did, it's Mg, it's not calcium, but the charge on the magnesium and calcium is still the same. So I apologize if I confused you with that. It's not CAS, it's MGS. But regardless, we'll notice again, it's the same charges. So I apologize for that. My bad. Anyway, let's move on to the next one. And then after this one, number 4, we will skip down to do some ones down here. Okay, so I'm going to leave some of these for you to do on your own. All right, number 4, we have aluminum oxide. So again, let's go find aluminum and oxygen. Oxide is oxygen. So aluminum we have here in column 3 of the periodic table, and these make +3 charges. And we have oxygen, which is O, and that is in column 6, so that makes a charge of 2-. So these are our 2 ions, so let's go write those on our sheet here. So we have Al, and this is going to be 3+, because it's in the 3rd column. And we have O, which is going to be 2-. All right, so now, again, let's switch back to our paper to show this using our Wonder Woman method. I'll make sure I write the right formulas this time. So we have Al, which is 3+, and O, which is 2-. So if we do our Wonder Woman, we'll take our 3 from our aluminum, drop it down onto the oxygen, take our 2 from our oxygen, drop it down onto the aluminum. So we will have Al with a 2, again, we don't bring the negative with, and then we have an O with a 3, and again, we don't bring the positive with. And then if we look at this, is there any common number that we can divide out from 2 and 3 that will still make these whole numbers? No. Okay, there's no common denominator between 2 and 3. So Al2O3 would be the correct formula for our compound here. So if we go back to our sheet, we can write that in here as Al2O3. And there we go. Okay? All right, so hopefully that starts to give you an idea of how to do these. I am not going to finish the rest of these ones, but I'll leave those for you to do. Again, this sheet is in the description of this video. Let's go take a look at a few of these ones down here. So now, these ones, they're giving us a chemical formula, and we have to name it. Okay, so this one's a lot easier because we don't need to deal with charges. So all we're going to do is we're going to name each element, and then we'll have to determine if we have to make any changes. So K2O. K is potassium. O is oxygen. However, remember that potassium is a positive ion because it is a metal. So potassium would make a charge of K+, and oxygen would make a charge of 2-. So oxygen is going to be a negative ion, and if it is a negative ion, that means that it's not going to have an ending of oxygen, it will have an ending of oxide. So this will be called potassium oxide for its name. And again, really, we just have to change that ending to "ide." Okay. Taking a look at number 12, we have MgI2. So Mg is magnesium, and I is iodine. Okay. Again, if we look at the charges, though, Mg is or magnesium is Mg and makes a charge of 2+. Okay, this can be found on the periodic table. I know I'm not bringing up the periodic table right now, but we did see magnesium up in this one up here, so I know it's +2. Iodine, I, is in column 7 on the periodic table, so it makes a charge of -1. It is a negative ion, and so that means that when we name it, it needs to have an "ide" ending. So even though we've written iodine over here, it does need to be iodide. Okay, it needs to have that "ide" ending on it. So let's take a look at number 13. We have Al, which is aluminum. We have Cl, which is chlorine. Aluminum is a positive ion, chlorine is a negative ion, and all negative ions need to have that "ide" ending. So this should be chloride. Okay, so aluminum, chloride. All right, we'll do one more here. Number 14, CaBr2. So Ca is calcium. Br is bromine. Again, the charges, though, here, calcium is a positive ion. It is Ca2+. And bromine is Br and has a charge of -1. It is a negative ion, which means it needs to have an "ide" ending. So the proper name for this would be calcium bromide. All right, so again, I'm going to leave the rest of these for you to do on your own if you want to. The sheet here is in the description of the video. So hopefully that gives you an idea, guys, of how you make chemical formulas with ionic compounds and how you put these things together. But again, as always, if you have any other questions, make sure you reach out and ask those. So, all right, that's it for this one. Thanks for watching, and I'll see you in the next one.